Hello, this is Mr. Manley. In this video, we are going to continue an examination of working with imaginary numbers. Once we have the imaginary number I, really it's pretty easy to work with. One thing is that it behaves very much like a variable. It can combine like terms of I just like I could combine like terms of a variable. The other thing that we are going to be using is what you should have seen in a prior study of the imaginary number, is that I squared is equal to -1. So this is something that will come up in our work with operating with imaginary numbers. And then there's one last piece of it that we will get to at the end of the video. So first of all, here we have two imaginary numbers. There's 3 minus I is an imaginary number, and -6 plus 6i is an imaginary number. We're looking here at adding them, and it is going to add exactly the way your intuition would tell you, or based upon the experience that you probably have already had with these. 3 plus -6 is -3, and -I plus 6i is equal to 5i. So there's no negative aspect that is happening when we're operating with these until an I squared shows up. So don't forget that. Just wait for the I squared before you introduce a negative element to the imaginary number. Here we have multiplication of two imaginary numbers, -3 plus 2i, -5 plus 5, -4 plus 5i. And multiplying these, we are simply executing a FOIL. So -3 times -4 is 12. And then on the outside, this -3 times 5i is -15i. On the inside, I've got 2i times -4, which is -8i. And then the last one here, 10i squared. So that's plus 10i squared. And that's 12 minus 10 is 2. And then -15 minus 8 is -23i. And I might have glossed over that. I don't know how quickly I glossed over that, but there's the I squared, right? So that's 10 times -1. And then that gave me the -10, which added to 12 gave me 2. Okay. And then lastly, we have division of imaginary numbers. And in division of imaginary numbers, we're approaching it the same way we would approach a radical in the denominator. So hopefully you have some understanding or some experience with the rationalizing the denominator. And that is, we don't want to leave a fraction with a radical in the denominator. No radicals. Well, I mean, considering where I comes from, it's not a radical, but it comes from a radical, right? So we're going to treat it in the same way. We do not want to have any I imaginary numbers in the denominator the same way that we do not want to have any radicals in the denominator. So in this case, and then another thing hopefully you remember is this term conjugate, as in A minus B is the conjugate of A plus B. So there's that concept or that definition of conjugate. So I want to use the conjugate up here of the denominator, -4 minus 5i. And I'm allowed to multiply by -4 minus 5i over -4 minus 5i, because that's just another form of the number 1, any number over itself, right? And this is the conjugate of this. So multiplying here, it's a couple of FOILs, right? Let's put the parentheses here to help us see the FOIL a little bit more clearly. In the denominator, I've got negative 4 times negative 4 is 16. And then negative 4 times negative 5 is 20i. And 5i times negative 4 is negative 20i. So those zeroed out, right? Did you see that? I had a 20i minus a 20i. And that's why we use the conjugate, because the outside and inside terms are going to zero out. And then on the last term, I've got minus 25i squared. In the numerator, negative 3 times negative 4 is 12. And then I've got plus 15 minus 8. So plus 15 minus 8 is going to be 7i. And we've got minus 10i squared. And what we want to do here is we want to deal with our I squared. So this I squared here is negative 1, right? That's going to be negative 1. And same thing down here, this I squared is negative 1. Okay? So we'll just deal with that and simplify as much as we can. That's 12. And then that'll be, here is going to be negative 10 times negative 1 will be plus 10. So 12 plus 10 is 22 plus 7i. And then in the denominator, I've got minus 25i squared. So that's going to be plus 25 because it's negative 25 times a negative 1 is plus 25. And that'll give me 41 in the denominator. All right, so that's really, that's good and that's correct. But there is this consideration of the standard form of a complex number is a plus bi. So if you consider that a plus bi and you look at what we have here, what do you think about, like, how could I rewrite that to put it in standard form? I would do this. 24 over 41 plus 7 over 41i. And that would be the correct standard form. And those are all the operations that we can do. I mean, we could go back here and we could say I could subtract, but we've seen everything, really. Addition, multiplication, division, and of course, subtraction would not be a big step further than what we've already done.